Hi, welcome to the video tutorial on MRCL Viewer Microscope software from Microcubic. This tutorial assumes that the cables are connected and the microscope is up and running. The software comprises multiple sections. On the top right, there are the main control buttons. Then the illumination controls and actuator controls with 3 different control options. On the left side, there are the camera controls and the scale bar integration, the camera preview, and finally, image and video capture buttons with HDR, focus stacking, and time-lapse options. Each section has an information button. Clicking these buttons opens the corresponding user guide about that section in full screen. We will now review the details about these sections and different image capturing modes. First, connect to the microscope by selecting the COM port from the top right corner. Note that the port number can be different for different computers. All values from the actuators and the illumination sources should be updated automatically. If a module shows NA, it means it is not connected. Check its cable and ensure that its blue LED is on. If there is a question mark, it means that the module requires initialization. You can initialize a module by clicking on its ID letter. All 7 actuators can be initialized individually. Alternatively, you can initialize all modules simultaneously by pressing the Home button here. Always use the master power switch to turn off the system, so you do not need to initialize every time you run the microscope. It will remember its latest settings, but homing once in a while may help to maximize the accuracy of the position measurements. The position values of the actuators should automatically refresh whenever an actuator stops, but you can also refresh manually by pressing the button here. During homing or regular operation of the microscope, if you observe an undesired movement, you can stop all actuators by pressing the emergency stop button. The microscope's camera is selected from the lower left corner. We recommend enabling the auto exposure from the camera control window for most imaging applications or when unsure about the camera parameters. You can also change the white balance or other camera settings from here if needed. The camera is moved to the negative tilting angles during the tilted imaging of transparent samples. Therefore, the preview must be rotated from the Rotate Image button. There is also a shortcut on the graphical interface to change the camera exposure manually. However, the camera does not automatically go to the auto exposure mode when the manual control is disabled. This must be re-enabled from the camera options window. Under the exposure control, another slider adjusts the digital zoom. This zoom affects only the preview window, not the captured images, and makes focusing easier. Pressing on the zoom icon brings back the default view. Alternatively, you can switch to the full screen mode to have a larger preview window. All captured images and videos are saved to the folder selected from here. The software will save to the desktop if a folder is not specified. The software features a dynamic scale bar that changes automatically according to the position of the camera axis. Currently, only 2 lenses, Lens 1 and Lens 2, are calibrated and can be selected. The camera resolution can also be changed from the camera control section. Other settings, for example, image format, scale bar color, time-lapse interval, and focus stacking parameters, can be changed from the main settings window. The lens calibration data can also be imported from here, but this needs to be done only once during the first installation. When the scale bar is enabled by selecting a lens, you can add measurement annotations from the top left corner. This will display live dimension values according to the position of the camera axis and the selected lens. You can change the position and dimensions of the line or the rectangle annotation by moving the vertices in blue. The annotations work in the full screen mode and at different camera resolutions. The measurement values will automatically change when a different objective lens is selected from the drop-down lens list. But before any critical measurements, check a sample with known dimensions and recalibrate the lens parameters. When done, you can delete them by clicking on the round dots or vertices in red color. You can also change the annotation's color and line width from the settings menu. For example, reducing the line width may help to align the line to the sample with better precision. It is also possible to add a crosshair at the center of the camera preview or a calibration line that shows raw pixel values instead of the calculated dimensions. The crosshair and the calibration line can be removed by re-clicking on them from the annotation list. You can add multiple annotations to measure the thickness of your sample or two-dimensional features. But please remember to check your system's lens calibration data from time to time using the provided calibration slide. Also note that when a measurement is done during the tilting imaging, the software does not yet automatically compensate for the camera tilt. You may need to correct your measurements in post-processing, especially when you measure the depth or height of 3D structures. Because this microscope can tilt the camera around two pivot points, points A and B, the effective tilting angle written on the image overlay is the arithmetic sum of both angles. Note that the values are updated only when the actuators stop. All parameters of the illumination sources can be digitally controlled from the Illumination control section. For example, you can control individual columns of the curved illumination, which can be used to create dark field imaging effects. In addition, a higher light intensity can be generated by enabling only the columns that are aligned to the sample, instead of the whole matrix, especially when more light is required when imaging at higher magnifications. The intensity of the spot illumination located on the base and individual LEDs and the color of the ring illumination can also be controlled. Because the close-up illumination and the ring illumination are not designed to be used at the same time, the close-up illumination is controlled using the same buttons on the graphical interface. Now let's briefly review the actuator controls. In the free mode, the longer you press the arrow button, the faster the actuator moves until it automatically stops at the end of its range. This mode is similar to controlling from the joystick. In relative and absolute modes, the actuators move according to the input values. For example, you can move the sample at 5mm steps or to an absolute position while recording a movie or while capturing photos between the steps. For example, here is a quick guide to capture cool videos of your samples. In the relative mode, start the sample rotation and tilting at a very low speed and start the video recording. At the same time, you can use the joystick or other buttons to control the zoom level or XY positioning. We recommend doing this at a low speed to better control the focus and position. Then stop the recording. For the actuators, you can wait until the program movement is finished or press the emergency stop button at any time. Then use your favorite video editing software to speed up the video. You can cut the beginning and the end if needed. Here is the result of our recording. You can move the sample using the mouse when the scale bar is enabled. The software will automatically center the position you click. This works at different camera resolutions and full screen mode as well. Depending on the software version, it can be the left mouse click or the right one. Another way to control the actuators is the keyboard shortcuts. The arrow keys directly control the XY stage. In addition, other modules are controlled using the arrow keys while holding the letter corresponding to a module. All these illumination parameters and actuator positions can be saved in a JSON file, so that particular imaging configuration can be recalled later. You can save different positions, tilting angles, and zoom levels using the Save button on the top. Then you can recall that configuration using the Open button. For example, you can go back and forth between two locations on the chip during an experiment. You can also save a video while the microscope travels from one position to another, or while the illumination changes. The saved JSON file is easy to understand and can be edited manually if needed. Also, if enabled from the Settings menu, a unique JSON file is saved for every captured image, almost like metadata. This would allow you to check or recall the parameters used in that particular image. Besides capturing regular photos and videos, the software can also perform focus stacking, HDR imaging, and time-lapse using the camera control buttons. For focus stacking, we recommend fully opening the iris diaphragm, reducing the depth of field. Press the FS button, focus on the first point on the preview by moving the camera axis from the joystick, and then focus on the second point. After the confirmation, the microscope will disable the joystick and automatically capture multiple images by moving the focus. If the process freezes for any reason, you can cancel and restart. You can then find the processed output image in the selected save folder. The software also saves individual raw images in a dedicated folder. You can use these images to do the focus stacking using a third-party software like Helicon Focus for more control on the stacking algorithm and for a better quality output. You can use HDR imaging to balance the dark and bright areas on the sample. First, check the minimum and maximum exposure values by manually changing the exposure. Then, enter the range into the Settings menu. Pressing the HDR button will automatically combine images at each exposure level. Like focus stacking, you can also use third-party software to merge raw images for a better quality output. For every HDR, focus stacking, or time-lapse process, the software automatically creates a new dedicated folder where it saves the raw images. The output images and the associated JSON files, if enabled, are then located in the selected save folder. And as the final feature for this tutorial, all parameters of the microscope can be monitored and controlled in real time using the built-in serial terminal window. For example, you can monitor the data from the joystick and the other status messages from the modules. In addition, you can send serial commands to move the actuators and control the light sources. This terminal is also used to configure and calibrate the modules. For example, you can configure the joystick and change the direction of each action according to your preference. For more on this and the list of serial commands, please check the PDF user manual. We are constantly adding new features to the software. Please let us know what you would like to see in the following updates. Thank you and goodbye.